This is Unit 8, Area and Solids, Preview Video 8.4, Part 1, Arc Length and Sector Area. Take a moment, sit tall, and inhale. Slowly exhale. Take a moment and get a parent signature. Don't forget a date, time, and location. I'd also recommend, I'm going to be slicing and dicing a citrus slice. So if you'd like to follow along with me, I recommend you just get yourself an orange or a lemon slice and a knife that is comfortable with and a paper plate. You could just watch the demo, of course. But if you'd like the more hands-on experience, you're welcome to get yourself some sort of slice, make it a relatively thick slice, about 1/4 inch, and have it available. We're going to be talking about arc length and sector area. It says, find the circumference and the area of the circle below. Assume the radius of the orange is 10 centimeters. Again, when you do diameter, always physically trace your diameter, because your diameter there is not 10, it's 20. So, of course, circumference. And I didn't say exact terms or decimal terms, so you can just leave it right at there. So all of today's lesson, if you can do circumference and area, it's very simple, because all we're doing is doing portions of the circumference and portions of the area. And what I mean is this. If I were to slice a 90-degree slice here, like this, slice it out, and I were to remove the pulp from the pith, this right here would be considered an arc length, a piece of an arc. And this would be considered a sector area, a piece of an area. Okay, so arc length is the piece of the circle's entire circumference. So although if this were 90 degrees, the measure of this arc is 90 degrees, degree curvature. Its length, if you will, if I were to flatten it straight down, its length is going to be a piece of the circumference. So get the distinction here. Arc length is a piece of this circle's circumference. In sector area, this would be the sector area, is a piece or a fraction of the entire area. Arc length and sector area. So an arc length is a fraction of a circle's circumference, a fraction of a circle's circumference. And what is a fraction? A fraction is a part We're just defining fraction over whole. Of is going to be multiplication of the circumference. So if I had here, let's go back to that 90 degrees, and we have that 10 centimeter radius, and I want to find the length of this, assuming that radius is 10, although in physicality it's not in this case. I should have had myself a grapefruit. But here, the arc length, what we do is to get that part, we take the measure of that central angle theta over 360 times circumference, which is d pi. So in this particular example, the circumference is 20 pi centimeters. So we would say the length of this arc right here would be 90 over 360 times 20 pi, which if you reduce it, 9 goes into 36, 1 in 4. And then I can take the 4 into the 20. So therefore, my arc length would be 5 pi centimeters. So a sector area is simply a fraction of the area. In this example, the sector area would be this little slice here. It is a fraction or a part of the area, a fraction of the area. Part is that theta angle, which is in the middle, over 360, times of area, which would be pi r squared. That would be sector area. So back to our 90-degree example. Using a 10 centimeter radius, our area of that orange slice, 90 degrees over 360 times the area, which is 100 pi. 9 goes in there 4 times, 4 goes into 100, therefore our sector area is going to be 25 pi centimeters squared. In the circle below, find the degree measure, box that word measure, of AC, and then find the arc length. Box that word length of AC in exact form. The radius length is 10 centimeters. So we're still using 10 centimeters. What is the difference between measure and length? Measure is a degree curvature concept. Length is something like meters, inches, centimeters. So here, the measure of this arc, degree measure of arc AC, is measure of a central angle to its arc the same. So the measure of the arc is 45 degrees. Measure means degree curvature. Fraction of circumference is arc length. Circumference is d pi. Trace it. Of course, that's going to be 20 pi. We want to do the arc length, so that's theta over 360 times d pi. Our theta in this case is 45 degrees. 45 degrees. Our whole is going to be, of course, 360. Part over whole, 360. Times 20 pi. Try to get in the habit of reducing as much as you can without a calculator. For example, I know 9 goes into both of these. 9 goes into both of these. So 9 goes into 45 5 times, and I know 9 goes into 360 40 times. I can still reduce. 5 into 40 is 8. So my arc length, 20 pi over 8, reduce again by 2. My final arc length is going to, of AC, in this case, is 10 pi over, actually 4 goes into both of those, not even 2. We can go farther than that. 4 goes in there 5 times, 4 goes in there twice, so it is 5 pi over 2 centimeters. Ta-da, you're done. That's exact terms. In the circle below, find the sector area, ABC, sector area. That's the area of this orange slice, again with a radius of 10. So we're going to find fraction of area. And to find the actual sector, we're going to go 45 over the whole, which is 360 again, times 100 pi. Try to get in the habit, as best you can, of hacking away longhand. So I'm going to kill 1 0 and 1 0. I know 9 goes in there 5 times, 9 goes into 36 4 times. I know 2 goes into 10 5 times, 2 goes into 4 twice. Now I'm down. I can't reduce anymore. So final answer here is 5 times 5 for the sector area, ABC, is going to be 25 over 2 pi centimeters squared. Now we're going to do it with the major arc here. Circle Q, the radius length is 9. Find the arc length of the major arc EGF. So we're going the length of that arc. And then the sector area EGF, sector area would be all of this. So follow our steps here. We're going to trace the arc EGF. Now the degree measure of the arc is the same as its central angle. So measure of a central angle to its arc the same. So the degree measure or curvature of that arc is 285 degrees. To find the arc length is going to be theta over 360 times d pi, which is circumference. Sector area, same thing, theta over 360 times area, which is pi r squared. Plug our numbers in and reduce. So our theta here is 285. Physically trace your diameter. Never use your eyeballs for that. That's going to be 18 pi. Down here, this is going to be 285 over 360 times 9 times 9, because we're squaring, pi. Now we just come through, we hack away and reduce. So I know that, if I look very carefully, 18 goes into 36 twice. with the 0. So I know that 18 goes into 360 20 times. Now cross that out, I have 20. 18 goes into 360 20 times. You're like, how did you know that, Miss Way? Because 18 goes into 36, so 360 divided by 18, just so most of you treat a calculator as if it's the voice of God itself. Okay, and now we're just going to reduce. We're going to divide both by 5. So I have 285 divided by 5. So if I divide this by 5, I get 37. Divide this by 5, I get 4 pi. That means my arc length, EGF, is 37/4 pi. Check for units. Yards, singular. Over here, we know that 9 times 9, 9 goes in here 40 times. And I'm going to divide both these by 5. This is going to be, once again, just realized I wrote that down wrong. This is 57, not 37, 57/4. Over here, 285 divided by 5, just so you're not paranoid here. 285 divided by 5 is 57. So this is going to be 57 over 8 times 9 pi. Come over here, 9 times 57. Did that by hand, so I know some of you that makes you nervous. So just to show you, 57 times 9, 513. So 513 over 8, and that cannot be divided by 8 or reduced. Pi, check units, yards squared. Ta-da! This page you're going to attempt to do on your own. Show your work. Do this in exact form. Try to do this without a calculator. Pause the video. Students, you're now checking your work. Hopefully you're just not copying. So arc measure, PQR, measure is degree measure, so that's going to be 210 degrees. Arc length is going to be theta over 360 times d pi. Sector area in exact terms is theta over 360 times pi r squared. Coming over here, that's going to be 210 over 360 times, trace it, 36 pi. And this one is going to be 210 over 360 times 18 times 18 pi. Should have reduced. Zeros cancel, so that's easy. 36 cancels, dot. Your answer in exact form is 21 pi. Let's check for units. No units, so that's just going to be units. That's your arc length. Down here, kill the zeros. 18 goes into 36 twice, and then the 2 goes into 18 9 times. So I'm going to have 21 times 9, and I get 189 pi units squared.